Good day, guys. This is Mr. Prince Maths and Science class, and in this video I'm going to be talking about set. And a set is a well-defined collection of objects called elements or members, and sets are usually written using curly bracket like this. Sets are usually written with curly bracket like this. Okay. For example, if we want to write a set of numbers like 1, 2, 3, 4, we are going to write it like this. Say A is equals to 1, 2, 3, 4. Okay. So, sorry. Let's say 1, 2, 3. Okay. And you can see from on my screen what I wrote. So E is an element of, that's what E symbolizes in set. Okay. So for example, in this notation we have A equals to 1, 2, and 3. So we can say that 3 is an element of A. Okay, 3 is an element of A. Okay, now this one, the E that has like a slash that crosses it, that symbolizes that the E is not an element of so and of so and so. For example, if we are given a number like 4, we can say that 4 is not an element of A. Okay, so we say 4 is not an element of A. Alright, so there's another one that says the next one is equal set. So whenever we say that two sets have the same type of numbers or the same type of elements, even if they are written in opposite direction, let's say they are written in a way that in a way that they are not in sequential order, they are still the same, because in set the order does not matter, and also you cannot repeat elements in set. So for equal set, if we have two sets that have the same type of elements, even though they are written in different orders, they are still the same set. So we can say like set A can be equals to set B if set B contains 3, 1, and 2. Okay, now empty set, this is the symbol for an empty set. This is a set that contains no element, and NA is the number of elements. Okay, so we have 3 elements here, 1, 2, and 3. So NA is equals to 3. That's the number of elements we have. If we add 1, 2, 3, and 7, then that will be 4 elements for A. So that's it for that. So now I want to explain types of set. So for the types of set, we have empty or null set. This is a set with no element. Okay, just like I said earlier here, no element. Okay, and another example is finite set. Another type of set is finite set. Sorry, a finite set is a set with a limited number of elements. So for example, we can say B is equals to set A, B, and C. So it stops at a particular number of elements. Okay, and an infinite set is the opposite. An infinite set is a set with endless elements. So for example, let's say we are like C is equals to, and we have something like this, 1, 2, 3, 4, and it just keep recurring and it doesn't stop. That's an infinite set. Okay, so an equal set, just like I explained earlier, an equal set is when two sets with exactly the same elements. I explained it above already. So an example is A equals to 1, 2, 3, and we have B equals to 3, 1, 2. So because they have the same type of elements for in each set, then we can say that these sets are equal. Okay, and number 5, we have subset. So a subset is a set where all elements belongs to another set. Okay, so for example, we have two sets. We have A, which contains 1 and 2, and then we have B that contains sets 1, 2, and 3. So we can say that we can find all this, or the set in A can be found in B. So we can say that A is a subset of B. Okay, so A is we can rewrite like this: A is a subset of B. Okay, so it's not a C, but it's kind of like a curved intersection. Okay, so that's it for types of set. So the next one is operations on set. And operations on set, we have all these ones are the symbols that we see between two sets. Okay, so for example, a union is when all elements in either or both sets, okay, all the elements is combination of all the elements in both sets. Or so now, for example, let's say we have A to be set contain element 1 and 2, 1 and 2, and then we have B to contain element 2 and 3. So if we want to do A union B, that will be now we are going to combine all the elements in both sets. So that will be 1, 2 and 3. And remember that in set you cannot repeat the same type of element, just one, and the other does not matter too. Okay, and the next one is intersection. Intersection is elements common to both sets. Okay, so just like we have A equals to 1 and 2, okay, and B is equals to 2 and 3. So we have to look for the elements that we can find in both sets. So if we do A intersection B, the only element we can find in both sets is 2. So that's the answer for that. That's intersection. And then another one is difference. This one connotes that if elements in one set, there will be elements in one set but not the other. So for example, we have A is 1 and 2, and then B is 2 and 3. Okay, so if we are to do A minus B, A minus B will be is going to be 1. Okay, so we are trying to say like A will be like the general set. So anything that we cannot find, anything that we cannot find in the other set, which is B, is what we are going to write down. So that will be 1. Okay, so and the last one is universal set. So universal set contains all elements being considered. So for example, if we are studying numbers from 1 to 10, okay, if we are studying numbers from 1 to 10, the universal set is like a general table that contains all the elements from different sets. Okay, so if we are studying numbers from 1 to 10, we just write that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is universal set. Okay, so also there are some formulas that you need to know. There are some formulas you need to know when solving problems on set. There are some formulas you need to know when solving problems on set. For example, let's say you are dealing with two sets, and we are still going to talk about Venn diagrams. It's not going to be in this video, it's going to be in another video. So let's say we are dealing with set with two sets, and then you are asked to find the number of A union B. Okay, so this is the formula. It will be n number of A plus number of B minus number of A intersection B. Okay, so for example, let's say you are given 3 sets. We have to find number for 3 sets like this. So the formula will be number of A plus number of A plus number of B plus number of C minus number of A intersection B, okay, minus number of A intersection C minus number of B intersection C, okay, plus the number of A intersection B intersection C. So make sure you keep this formula in mind. It's a very important formula, because let's say you know the formula for the number of you are finding A union B union C. If you wanted to find the number of A intersection B, let's say you wanted to find this one, you just make this one the subject of formula, and then you bring this one to the other side, bring this one to that side. Okay, so these formulas are very important, because when you start to solve problems on Venn diagrams, you see the importance of knowing type of formulas like this. Okay, and there are some laws in sets. One law that I'm going to talk about is commutative law. Commutative law states that A union B is equals to B union A. No matter what order you write it, they are equals to each other. And A intersection B is equals to B intersection A. Okay, it's just the same thing as when you write 2 times 3 is equals to 3 times 2. Okay, or you write 2 plus 3 is equals to 3 plus 2. No matter what order you write it, it's still gonna give you the same answer. Okay, and another one is associative law. Associative laws. And associative law says that A union B union C is equals to A union B union C. Okay, or it will be A intersection B intersection C. Okay, is equals to A intersection B intersection C. Okay, so for example, let's say you are playing with three numbers, 2, 3 and 4. Let's say we are doing 2 times 3, okay, times 4, okay, equals to 2 times 3 times 4. So now let me solve it and let me show you how they are equals to each other. So 2 times 3 is 6 times 4, okay, and 3 times 4 is 12. So 6 times 4 is 24. 2 times 12 is 24. So this is what associative law is about. And the next law is distributive law. Distributive law. And distributive law states that A intersection B union C is equals to A intersection B union A intersection C. Okay, and it says that A union B intersection C is equals to A union B intersection A union C. Okay, and we can prove the distributive law with three numbers. We can use 2, 3 and 4 again. So in this part we can say 2 plus 3 times 4, okay, is equals to 2 times 3 plus 2 times 4. So we're trying to use this to represent this one. Okay, so 2 plus 3 times 4 is 12. Okay, and we have 2 times 3 is 6 plus 2 times 4 is 8. So 2 plus 12 is 14, and 6 plus 8 is 14. So that's how to prove distributive law. Okay, and the next type of law is identity law. Identity law. And identity law says that A union an empty set is equals to A. Okay, or A intersection union is equals to A. So this is what the identity law states. Okay, and another law is complement law. Complement law. And the complement law states that A union A prime, or complement of A, I call it A prime, but this is complement of A, is equals to the union. Okay, and A intersection A prime is equals to an empty set. Okay, and A prime, A complement of A complement is still going to be A, because this complement will cross out each other. Okay, and when we are trying to use A intersection A prime or complement of A, is a set that does not belong to A but belongs to the universal set. So if we have to do, now that we have two different sets, because A complement of A is going to have a set that is completely different from A. Okay, and so when we're trying to look for like two sets, when we're trying to look for a set, so the sets between complement of A and A that are common, we are not going to find any set that is common. So that is why we are going to have an empty set. Okay, and the first one that says A union A prime. A union A prime is just like the combination is the combination of the set of A and the sets that do not belong to A. Okay, so when you combine everything together, you get a universal set. So that's it for that. Okay, and the same thing with this one is A intersection of A intersection universal set is equals to A. And the last law is the Morgan's law. The Morgan's law. Okay, and the Morgan's law states that A union B prime is equals to A prime intersection B prime. Okay, and it states that A intersection B prime is equals to A prime union B prime. Okay, so that's it for this video. So I'm going to do more examples in the next video, and we'll do some examples on Venn diagrams. And I hope you understood the concept. If you have any question, you can drop it in the comment section, or you can send it to my email, princewill2016@gmail.com. I will drop it in the video description. And thank you for watching. Make sure you share the video, make sure you like, make sure you subscribe to the channel. Thank you and peace out.